Uh, Good evening, my dear students. In the last period, we have studied about the uh, calculus structure of benzene and resonance structures. So today in this period, we want to determine or we want to prove that benzene has got the two different structures which are known as the calculus structure. Now let me read the question for you. Before I read the question for you, let me make sure that can you see the screen? बच्चों क्या आपको पूरा स्क्रीन पे
Yes,
मेरे
sir.
Yes, sir.
है वो दिख रहा है?
Yes, sir.
Can you read first two three words of the question?
Write down the product
Write
of
down the
Write
product.
down the product
Thank
of
you, my dear students. I'm once again thankful. Let's move forward. Let me read the question for you. Write down the products of ozonolysis of 1,2-dimethyl benzene. That is what it is known as Ortho Xylene. Now, first of all, my dear students, we need to study the structure of Ortho Xylene. What is Ortho Xylene? So please understand here, my dear students, this is what it is, your benzene. This benzene has, if benzene has got two CH3 this way, this kind of structure of benzene is known as orthoxylene. Please understand, the name of this compound is orthoxylene. We call this compound as orthoxylene. You know, if we take benzene and in the benzene all these carbons are available, suppose we give 1 2 3 4 5 and 6 numbers, then if any two adjacent number, let us say 1 and 2, at that if we have two same or different groups are available, this kind of 1 2 benzene is known as ortho. So 1 2 position is known as ortho, 1 4 position is known as para, and 1 6 position is also known as ortho, my dear students, and 1 3 position is known as meta, or 1 5 position is also known as meta. So once again, my dear students, let me explain this to you, that if we have benzene, in this benzene we have various carbons, 1 2 3 4 5 6. Now what happens if we have two methyl group at adjacent position? We will call it orthoxylene. For ortho we just write ortho and then we write xylene. Suppose if we have these two CH3 group are present at 1 and 3 position, you can see this is 1 and this is 3 position, CH3 and CH3, then we will call it meta. For meta we will just write M, meta-xylene. Same way, my dear students, if this CH3 group are present at 1 position and at 4 position, then it will be known as para, para-xylene, my dear students. Same way, you know, if we have CH3 present on first position as well as on the sixth position, my dear students, that will also be considered as a orthoxylene. And if we have the methyl group present at the first position as well as, my dear students, at the fifth position, that will also be known as the meta-xylene. So this is how, my dear students, we understand about the various positions into the benzene. Now you will be very clear as a about the various types of xylene. Do you have any doubt? You can ask, my dear students. बच्चों अगर आपको कोई डाउट है तो आप पूछ सकते हैं. बच्चों कुछ पूछना है आपको? प्लीज बता दीजिए। डू यू वांट टू आस्क एनीथिंग? ये समझ में आ रहा है आपको? एक्सपेक्टिंग अ रिप्लाई।
Yes, sir.
थैंक यू।
Yes, sir.
थैंक यू। किसी को कोई डाउट है तो आप बिना झिझक पूछ सकते हैं। नाउ लेट अस मूव एंड अंडरस्टैंड अबाउट द ओजोनालिसिस। So please understand about the ozonolysis. My dear students, please understand that if you have C double bond C, we are not much worried about any other compounds or any other groups bonded to this carbon. So any C double bond C, if it is allowed to react with ozone, it first produce a kind of compound which is known as triozonide. So this double bond get broken, my dear students. So we have C, then we have another C. This double bond get broken, and in this position, the 3 ozone atoms are being bonded. This is what it is known as triozonide. Triozonide, this is what it happens. And this triozonide, my dear students, if it is allowed to react with water further, it decomposes in this manner. So if we have a water molecule present with us, it gives us the 2 compound. This C and C, these 2 bonds remains as usual. This bond become double bond and O. This is what it happens, and we will have the next product. This C and this O bond will turn into double bond O, and these 2 groups which are present over here and here, they remains the same. So now if we put these groups, suppose if we have R1 and R2 here, so we will get in the product R1 and R2. This is R1 and R2 over here. If we have this R3 and R4, same way, my dear students, these R3 and R4 will also remain here, and you will get R3 and R4 as a product. This is what it is, the ozonolysis method. Now think, if your R1, please remember, my dear students, we have R1, R2, R3 and R4. Suppose your R1 is H. Let me write it for you, my dear students, that suppose your R1 is H, R2 is CS3, R3 is CS3 and R4 is CS3. Then you will get the first product. Let us say this product is first product and this product is second product. So the first product you will get is H, then C, double bond O, and then you have CH3. This is nothing but your CH3, CHO. And if your R3 and R4 are both CH3, then you are going to get CH3, bond C, double bond O, bond CH3. This is nothing but your CH3, C double bond O, CH3. This is what it is known as propanone. So this is how, my dear students, we can get the various products for our ozonolysis. In ozonolysis, we will get either aldehyde as a product or ketone as a product. Please remember, in ozonolysis, the products what we get may be the aldehyde or ketone. Products of ozonolysis are carbonyl compounds, most probably the aldehydes and ketones. So in 12th standard, when you will study this ozonolysis as a method of preparation for the aldehydes and ketones. So aldehydes and ketones are prepared by using this ozonolysis. So I hope, my dear students, now you would have understood it. If you have any doubt, you can ask me. बच्चों अगर कोई डाउट है तो आप पूछ सकते हैं, प्लीज। बच्चों,
No doubt.
thank you, my dear students. Then let's move and understand the ozonolysis of our benzene. So my dear students, here we have a benzene. You can see that I'm going to draw the structure of benzene. See, this is benzene. Let me show it with the carbon also. So you can see that this C. See, please remember that your ortho xylene is in this form. This is your ortho xylene. One CH3 is present here. Please remember, my dear students, that in ortho xylene you have one CH3 present over here, and the next CH3 is present here. So this is what it is, your ortho xylene. So let me show you, my dear students. Here we have carbon. This carbon is bonded with CH3. Then we have again carbon. This carbon is also bonded with CH3. Here we have double bond. Then, my dear students, here we have C. Here, my dear students, even we have C. This is even C. This is C. And this is what it goes. Now you can see that the double bonds are here and here. And all these have hydrogen present with them. So this is interesting to study. Now, my dear students, you can see that we have 3 double bond. So we will use O3 3 times, because for these 3 double bonds we need 3 O3. So here the ozonolysis takes place. So as you can see, my dear students, that we have got the ozonolysis. Let us see what happens. So let me show it to you, my dear students, that you have CH3. You can see that this bond, this bond, this bond and this bond are being broken. Being pi bond, they are first broken, and instead of that we will get the ozone or triozonide being formed. So I'm just going to draw this for you. See, we have CH3, then this C we have, then you can see that we have another C here that is bonded with CH3. Then there is no double bond, so this bond is not going to be broken. This CH, then again, my dear students, we have the another carbon which is bonded with the hydrogen. This double bond is being broken. Then again we have, my dear students, this carbon and carbon single bond which is not going to be broken. And then, my dear students, we have double bond here. So you can see that this carbon and this carbon has got single bond, so it is not going to be broken. Then, my dear students, we have double bond, so this double bond is going to be broken. Now I will show you how we can get the ozone being bonded over here. You can see that this is how the ozone is being bonded, my dear students. So in each case, we will get this triozonide formed. You can see it very easily. It's quite simple for you to understand. So this is how this triozonide is formed into the benzene, my dear students. All these 3 double bonds which were present over here, they get broken. Now these bonds are going to be broken and we will get some of the products. Let us see how these bonds get broken. So you can see that this bond here is going to be broken in this manner. It is very easy for you to understand. And this way, you can see, my dear students, that these bonds are being broken. So you can see the first product, what you get from here. See, from here, my dear students, you are going to get, C, this C with double bond O. You can see this is C, this C and this O will be double bonded. Then you have CH3 over here. Then, my dear students, there is a bond between this carbon and carbon. This carbon has got H, and then you will have again the double bond O. So this product is nothing but your H, C double bond O. Then again you have C double bond O and CH3. This is the first product. What the next product you maybe get from here, my dear students? Let me show you. This is the next product what you may get. So this next product what you are supposed to get is this, that you have this CH and C double bond O. This C and this O are going to have the double bond. This is C double bond O. Then again you have H. Then this carbon and this carbon are bonded with each other. Again you have hydrogen, and this is going to be again double bond O. So this is how, my dear students, we are going to get the next product, and the next product is H, C double bond O, C double bond O and H. This is how. Now what is the next product that we may get from this? So my dear students, here again you can see that you have hydrogen. This hydrogen is bonded to the carbon. This carbon and oxygen will make the double bond O. Then this carbon and carbon is bonded with each other. Then again you have CH3 here. You can see, and this C double bond O, you will get it. So the next product what you are going to get is, let us start from here, H, then you have C double bond O, then again you have next one, that is C double bond O, and then you have CH3. So this is how, my dear students, if you look at, you will realize that this product and these products are same, and then you have the another product. So this is how, my dear students, we get the various products. If you have any doubt, you can ask me, my dear students. Is there anything which you could not understand? क्या बोला बेटा, सुनाई नहीं दिया? Please reply.
No doubt, sir.
Sure, understood everything?
Yes, sir.
Yes, sir.
Okay. This product, my dear student, is known as glyoxal. Can you see I have written glyoxal?
Yes, sir.
Yes,
And
sir.
these two products are known as 1-methyl glyoxal or methyl glyoxal. Methyl glyoxal. This is also, my dear students, we have methyl glyoxal. So if this kind of structure of benzene it undergoes the ozonolysis, we will get two products. Can you name the two products? What are the two products that we have got, my dear students? Can you name them? See, we got glyoxal and methyl glyoxal as product. Now, my dear students, let us move and understand the next kind of structure. Now, my dear students, suppose we have this Ortho Xylene in this particular form. Please, all of you, pay attention. In the last period, we have studied about the glyoxal, which were having this kind of structure. Suppose this time the double bond is present over here. So let me write the structure for you, my dear students, that we may have this CH3 bonded to the carbon. This carbon is bonded to the another carbon, and you have CH3. Then, my dear students, here we have double bond between the two carbon, and then we have hydrogen. Then again we have bond and hydrogen, my dear students. Then, my dear students, we have carbon, which is bonded to the double bond, and then we have hydrogen bonded to this carbon. Then we have another carbon bonded to the hydrogen, and then we have bond, and here we have the double bond. So now this is the structure of benzene that we have, which is, my dear students, we are going to allow it to react with 3 ozones. So we may take 3O3 here, my dear students. So as we have, my dear students, the same kind of ozonolysis takes place. So here ozonolysis takes place. As this ozonolysis takes place, my dear students, we are very much aware that we may form the three ozone molecule added to this benzene structure. Let us start with this. Let me show you, my dear students, that which bonds are going to be broken. This bond will be broken, this bond will be broken, and this bond will be broken. So we will have CH3 that is bonded to a carbon, that is C. This bond remains the same. This time this bond is not going to be broken. Then this bond between these two carbon is going to be broken, so we leave the gap, and then we have carbon and hydrogen. Then again the single bond remains the same, and we have carbon and hydrogen. Then this bond between these two carbon is going to be broken. Then again, my dear students, we have the bond between, let me give you the number 1, 2, 3, 4, 5 and 6. So the bond between 1 and 6 is going to be broken, my dear students, and then the bond between 6 and 5 remains as usual, and both these carbons are bonded to hydrogen. So my dear students, now let me show you how the three ozone molecules are being added. You can see that one oxygen is being added in between these two carbons, another is in between these two carbons. Wherever you have, or whenever you have had the double bond, there the oxygen is being, or ozone is being added, my dear students. You can even have this oxygen and oxygen here, and you may even have this oxygen and one more oxygen here, which are bonded to the carbon. So this is how we can easily understand that three ozone molecules are being added. Now they are going to be broken. So let us see how the bonds get broken. You can see, my dear students, this is how the bonds are broken. It is very easy for you that you can understand this breaking of bonds. So now let us see what are the various products we may get. The first product we may get out of this, then the second product we may get out of this, my dear students, and this is what it gives us, the third product. So let us see what kind of products we are going to get over here. You can see that CH3, we have this CH3 which is bonded to carbon. This carbon gets double bond with this oxygen, so we will have double bond O. Then again we have carbon and double bond O. Then we have CH3. So this is the first product. What is the next product that we can get here? That we can get H. Then, my dear students, this C, HC, double bond O. Then again we have this C and double bond O. And then again, my dear students, we have H over here. And same way, if you look into this, we are going to get H, this H, then my dear students, this C, then we have double bond O. Then again we have C, this is the C, and then double bond O. And then, my dear students, H. So we are going to get, the first product is CH3, C double bond O, C double bond O, and CH3. Then we may get H, C double bond O, C double bond O, and H. And this type of two molecules of this we are going to get. Now, my dear students, please mind well that this particular product is known as 1,2-dimethyl glyoxam, 1,2-dimethyl glyoxal. And here we just get glyoxal, 2 moles of glyoxal. 2 moles of glyoxal. So here, my dear students, in the last kind of resonance structures of benzene, this is the second resonance structure of benzene. In the first resonance structures, we have got the glyoxal as well as methyl glyoxal. But in the second resonance structures, we have got 1,2-dimethyl glyoxal. Dear students, do you understand this? If you have any doubt, you can ask me. बच्चों, ये जो पूरा डिस्कशन मैंने किया, उसमें अगर आपको कोई डाउट है तो आप लोग पूछ सकते हैं. कुछ पूछना है बच्चों? Okay. So this is how we understand the resonance structures and their ozonolysis. Now let me write the final reaction, my dear students. if benzene undergoes the ozonolysis, here we take 1 mole of benzene, here we use 3 mole of ozone, and then if ozonolysis takes place, my dear students, we will get the various products like glyoxal, H, C double bond O, C double bond O, and H. We may get methyl glyoxal, that is your CH3, C double bond O, C double bond O, H. And my dear students, apart from that, we will also get 1,2-dimethyl glyoxal, that is CH3, C double bond O, C double bond O, CH3. So all these 3 products we get simultaneously. We get all these 3 products on ozonolysis of benzene. What do you understand? It proves that what does it prove? Benzene is resonance stabilized.
सर आप आवाज नहीं आ रही है, कट रही है।
हाँ बेटा, अभी आ रही है आवाज?
हाँ सर अब आ रही है।
Thank you. So we can come to know that it proves that benzene is actually made up of true structures. So actually your benzene, what we write this way, is made up of 2 different structures of benzene. But if we say if it is Ortho Xylene, my dear students, then this on ozonolysis will give us 2 products. What 2 products are we going to get? Glyoxal and methyl glyoxal. And this on ozonolysis, my dear students, will, Ortho Xylene, this way we can show, will give us glyoxal plus 1,2-dimethyl glyoxal. But when we do the ozonolysis, my dear students, we get all these 3 products. We get all 3 products. They are glyoxal, methyl glyoxal, and dimethyl glyoxal. Simultaneously. And that is why we can say that this 1 and 2 structures actually makes this hybrid structure of benzene, and this is the proof. This reaction is proof. This reaction is proof that benzene is hybrid of two canonical structure. Benzene is hybrid of two canonical structures. So this is how, my dear students, we can prove that it is going to be the or benzene has got two different hybrid structures. If you have any doubt, you can ask, my dear students. बच्चों कोई डाउट है क्या?
No doubt, sir.
Okay, my dear students, then I hope you have enjoyed the class. Wish you happy learning.